Espresso Talks by Sphere Energy. Welcome back to Espresso Talks. And today I'm super excited to have not just one, but two great minds behind Limatica with us today, Paul and Thomas, as well as Lukas Lutz, co-founder of Sphere Energy, who I think does not need any further introduction, as you all should know him very well by now. Now, before getting into the deep stuff, I would suggest starting with a little introduction round for everyone who doesn't know you yet. Maybe who are you and what are you doing at Limatica?
So maybe I start first. Thomas Günther, my name. 6 years R&D at Technische Universität Chemnitz. Always with a focus on battery diagnostics, bringing, let's say, laboratory scale measurement approaches to products, to cell production lines. Later on, I moved to Thyssen, integrating these measurement technologies into formation equipment. And 3 years ago by now, left Thyssen and founded Limatica together with Paul, facing a specific problem in cell production.
Yeah, so I'm Paul Wischel. I'm working with batteries for more than 15 years now, with a background in production engineering, but then switched to R&D in measurement technology for cell characterization. Also at the university for many years, and then switched also to ThyssenKrupp, where I was in the end responsible for formation hardware development. Left ThyssenKrupp in 2022 to tackle, together with Thomas, a very specific problem that arises when you scale up production.
Yeah, so maybe Limatica, what's the story behind it? What was the spark of starting it?
Okay, so from our background in industry, we were faced with the task in designing cell finishing equipment. And cell finishing in battery manufacturing usually incorporates electrolyte filling, pre-charging and formation, and aging and end-of-line steps. And when you want to scale this, certain processing steps become really big. Formation is a big point because you need an insane amount of charging and discharging channels for each battery. And another big pain point is aging in the cell production, which is actually a quality assurance step. So what you do is you measure the voltage drop over time of each battery, and a battery that shows a high voltage drop is a bad battery and is sorted out. But if you do this with 10 batteries in the lab, it's not a problem. You do this with 100 batteries, it's not a problem. When you do this with 250,000 batteries per day, it becomes a problem because the measurement time is really long, usually up to 2 weeks. So the sheer amount of cells that you need to store is a big problem when you scale up. So, and back in our history, we worked with the formation step, which is charging, discharging, but we were well aware that this aging step is a big problem. And because we are, from our background, measurement technology guys for batteries, we said, okay, we must solve this problem because it's a real big pain and it has some other implications for the overall process that is a big burden for cell manufacturers.
Now we're already deep in the topic, which I like a lot. But when we now zoom out a little bit and look at the European Gigafactory scene, right? The news was not so covered with a lot of positive news over the last, let's say, 2 years, right? We heard all recently about Northvolt, which not only scaled down, but turned out to be bankrupt in the end. So maybe, Thomas, you can talk a little bit about the European Gigafactory scene. With Gigafactories, we mean Gigafactory scale battery manufacturing. Maybe you can shine some light on what is the current status, especially with the new elections in Germany, but also with the trends within Europe. How do you see the manufacturing scene?
So when you try to give it an overall conclusion, and I would say it's challenging. Let's say especially Asian competition is quite advanced, has lots of experience. When we look on the European players, there have been bold promises. Let's say, even knowing that you need to, let's say, gain a lot of knowledge. So there was not this much experience present as compared to some Asian players. So when we, for instance, look at Northvolt, so you need to ramp up a new factory with a new chemistry, with lack of experience, and this can become very hard, especially scaling things gets very hard. As Paul said, starting from a small sample line, pilot line, this step to Gigafactories it's a really big challenging issue. And for our point of view, this as we started Limatica, we knew this is something you need additional tools to make this process more robust, the scaling more robust, bringing new factories to life, and making this happen actually needs a different point of view, needs additional tools to cope with this lack of experience we have today. Yeah? So this is my point of view here.
So actually industry and also society was quite enthusiastic about the possibilities that we would have with new batteries in almost everything, every part of life. So starting from mobility, renewables, and every other thing that can be done with batteries. But soon after that, they realized, okay, it's not just chemistry development in a lab, but it also means building supply chains. It means building up production know-how. And the industry actually faced and is still facing an uphill battle on gaining the same experience as Asian competitors have now in a much shorter time, with a higher burden considering cost. So labor cost and energy cost and everything is much higher in the Western world. And this together forms an insane challenge. And we've seen this in the last year, essentially, that everything related to scaling up battery industry slowed down a little bit. So we heard big promises, but we saw that the reality creates a little bit more challenging tasks for the companies. And they are still working on that, but they became a little bit more, let's say, silent. I wouldn't say silent, but a little bit more careful on what they promise.
What would you say, to be maybe a little bit more specific? What are the one or two? Everybody's talking about battery manufacturing is challenging, right? What would you say is the one or two challenges that really are key right now to make us competitive, aside from the cost point that I would like to discuss in a minute? But what are the process or engineering challenges right now today that maybe Northvolt cracked by and the others need to solve to be successful?
Maybe from process point of view, it's feedback time. So when you look on the manufacturing process, especially when it comes to aging, where we are focusing on, it's an insanely long-lasting process step. You take, depending on cell type, cell size, it takes 5 to roughly 14 days. And when you look on controlling a process and you do some manufacturing and you do not know, did it actually work? And your most earliest point in time where you get the feedback, did it work out, is 10 days later. Let's say you have to produce scrap for 10 days and then you realize, I need to change something. But in addition to that time in the process loop, you have very little of additional information. As Paul said, you just have the voltage drop as a quality metric. Let's say it's oversimplified a little bit, but you almost have just the voltage drop as a quality indicator, and the quality indicator itself doesn't tell you the reason. It's not capable of doing this.
So you just know good or bad, but not why.
You just say above this limit, it's okay, or below this limit, it's not okay, but you have no clue what led to this issue. And with the dead time of this, with this big dead time, you have two big problems, or let's say two big reasons why, in my point of view, scaling cell production in Europe is kind of hard. Yeah.
So just to add, it's the sheer size that we're talking about is an issue, because the numbers of cells produced by each of those production lines is huge. It's beyond imagination of a normal.
Can you put some number? I know we discussed over lunch a little bit.
Just a rough number. So when you have a production line that produces per year roughly 15 gigawatt hours of cell capacity, without even considering scrap and everything, we're talking about more than 100 tons of batteries produced per day.
100 tons.
So this is huge. It's the logistics behind it is huge. It is an issue. The logistic outside the factory and of course the logistic inside the factory is an issue. The second topic we are facing is cost. Energy cost is of course an issue. Northvolt tried to tackle this with their factory up in the north where they have a vast amount of renewable energy available. Labor cost is an issue. Equipment cost here is higher. The requirements from a building perspective, environmental perspective is higher. So this is more challenging.
Maybe let's stay on the cost side for a moment, which is, I think, when we talk about Asian competitors, always the number one topic that everybody talks about. You focus now with Limatica on the formation, on the aging part, to be specific, part of the process. Can you tell us maybe a little bit more about the economics? Why aging is such a, we heard now that it just takes long, these 10 days to get feedback, but from an economical perspective, how would you say is aging a CAPEX intensive process, and then also maybe elaborate a little bit on the OPEX side and how you with Limatica try to change that game?
Okay, so from a CAPEX side, the investment you have for aging, well, first let's just explain a bit more what aging means. So we end up having the cell fully produced and initially charged, and then the cell is aged, and we are storing the cell to measure the voltage drop over time to take out cells that are essentially bad, that show a high self-discharge. So this is what we're doing. We do this over a longer period of time, usually 1 to 2 weeks.
When you say we, you mean that the industry is
state of the art.
Yeah, state of the art.
State of the art in a large factory. So 1 to 2 weeks. That means each week we need to store a few hundred tons of battery cells produced. So per day, 100 tons and times days. So we need to store them. Then we need to shuttle these cells around in the factory to bring them out of storage to the measurement station and back to storage. And this is the effort we need to put into this. So from a CAPEX point of view, we have, of course, the building, which is...
Are they big?
Yes.
Kind of big.
Many football fields. So in a normal factory, the cell finishing and aging process takes up more than a third of the overall area of the factory. It's quite huge. So we're talking about football fields full with storage, high-rack automated warehouses. This is expensive. The building is expensive to meet all the requirements. From the legal point of view, costs some money. Asian competitors, especially in China, can get around this a little bit more than we can. We have some energy cost due to climate control of the storage areas and all the logistics in this high-rack storage areas. This is more the OPEX side. From a labor point of view, it's not labor intense because it's fully automated. Usually there's some maintenance stuff, but it's not an issue. So the biggest part is CAPEX. And we're talking for a line. We're talking about costs in the range, let's say 10 to 20 million a year. What this costs, depreciation, OPEX, energy, anything. So
it's a bucket to jump in.
Yeah. So a real pain point for the industry, and the other pain point comes from the process itself. The data issue, let's call it. As Thomas pointed already, the process takes like 2 weeks, and in the end, we only have a voltage drop value. So we have our whole manufacturing process, which takes a few days in total, and then it takes 10 more days, roughly, to select good from bad cells. But in this 10 days, you have already produced many more cells. So if there is a problem,
It's accumulated.
you will detect it really late and you will have a big problem. So this broken feedback loop is the big pain point. And this is critical in production, detecting problems, and is essentially or especially critical in ramp up. So the European industry is more into the ramp up issue, like starting to production, getting everything running. So they need fast feedback, but they do not get it. So this is a really big pain point for them currently.
So maybe I can jump in again. So the feedback has even more, let's say, dimensions. One other really important point here is as long as you didn't do this quality metric here, cells are potentially dangerous. So, and as long as you do produce cells without being able to distinguish good from bad cells, but you need to store them all together. When you think about insurance companies, they don't like the situation that you store lots of batteries and you cannot tell which one might be hazardous and could cause some fire or other incidents in these factories. So when you look onto this problem from the insurance company point of view, getting feedback more early would be quite nice. Let's call it like that.
One last point to add is the bound capital. So you store batteries for like 10,000 to 20,000 cars over this period, and this is bound capital that you want to reduce.
I mean, maybe just to jump in on a point you mentioned earlier, you were talking a little bit about data, and those 100 tons of battery cells just sound like a huge gold mine of data that's just waiting to be unlocked. So maybe more about your process. What are you actually trying to do? What is Limatica trying to solve?
So what we actually do is we create a new quality metric for the battery. When we started, let's say from our background, we are measurement engineers. We know how to measure things. And when we started, we have had, let's say, kind of the process the requirements in mind, how this should look like, what it should do to be integratable into a measurement production, a cell production line. And with a clear view on what this type of measurement or what we do with the cells, what it should do and what it shouldn't do. We talked about risk before, so at first hand, we shouldn't apply any current to the battery to not maybe cause some risk. We should be able to gather more data in a shorter period of time to get some additional insights. And what we knew, all the measurements approaches right now being used in the cell production lines, they did not really have the, let's say, from our point of view, the right perspective. So we talked about self-discharge as a major metric on how to select good from bad cells at that point in time. And what we have in mind as we started our company was measurement approaches that actually ask the wrong question. So we check on the self-discharge if the self-discharge is too high or too low enough for a battery or too high. But the real question from our point of view was, why is it? Is there some intrinsic activity of a battery which leads to self-discharge or not? And this is where we started to develop a measurement approach to actually quantify how much intrinsic activity I have there and to be able to do the selection of good from bad cells quite fast compared to storing batteries today, days to weeks. We can do this in minutes. So this is amazing. Our point of view, it's going to be a big game changer in the cell production industry and maybe others later on, but for now we are focusing on closing this feedback loop away from days or weeks waiting towards minutes of measurement and getting this instant feedback for quick selection of batteries, and let's say mitigating certain risks when you, as long as you're not able to do a fast selection or a fast separation of good and bad from good and bad cells.
Yeah. Just to add, the problem that the cell manufacturers currently have with this process step is when the cells come out of the previous process step, the formation, there's still some relaxation going on, meaning that the cell voltage slowly drifts towards a stable value. And this is overlaid with the voltage drop due to defects inside the cell. And to discriminate those two, they have to wait. The self-discharge influence is quite small. Additionally, there's a temperature influence, which is actually much higher than the self-discharge influence. And the classical approach is just waiting, measure over a prolonged period of time until the self-discharge part in the measurement value actually is dominating the measurement. And it needs a little bit of a paradigm shift to look different at the cell and at the measurement problem itself to get around these problems. So we started to look that way. We knew from our previous work what is required for any method to scale into the Giga-Scale. So as Thomas pointed out, you need to have it as simple as possible, easy to integrate, fast and cheap. And this is what the manufacturers all ask for. And we said, okay, we want to look for what's going on inside the cell. We want to look for intrinsic activity. So the activity that is inside the cell due to defects. And to have or to be able to look on these intrinsic activities, we need to change how we measure. So we started working with the cell voltage noise. So the cell voltage is a stable value, and then on top of the stable, more or less stable value, on top of that, there's small fluctuations. And we started to analyze these fluctuations. We built our own hardware that is able to resolve it with very high resolution, both in the amplitude and also in time. So we measure much faster than what is state of the art, and with much higher resolution. And we then analyze this noise, and this noise shows differences depending on the intrinsic activity. And intrinsic activity is proportional to self-discharge. So this is the link, and we are developing this technology because it is a cheap electric measurement. It, from a measurement point of view, it gets around the drift issues and the temperature issues because our measurement times are much shorter. So the cell doesn't drift in these very short times, and it provides more information in a short period of time. So this is what they are looking for. And this is what actually is the core of Limatica.
Amazing. So hardware and software.
It's both. It's dedicated hardware that is ready to use for an industrial scale. So there are some requirements for that. So it's not pure lab equipment. So it must be scalable. So it must be cheap. And there's also the software part of it to be able to analyze the noise and to learn from as many battery measurements as possible. So especially during large-scale production, we face the problem of measuring 250,000 cells or more a day. So there's a lot of data handling going on, and we have developed the analytics with this in mind. And the final goal is also to learn from measurements of different manufacturers, combine this knowledge, and provide cell manufacturers a tool that gives them the cell quality evaluation much faster. And there's the hardware aspect and let's call it software aspect to it.
And Thomas, can you maybe elaborate a little bit on where you stand currently in your career as a startup or as a company? like you're working already with some of the manufacturers. Maybe you can tell us a little bit, obviously without naming specifics, but just in general so people understand where you are currently.
Currently, we're doing lots of measurement campaigns. So it's all about getting data, collecting data, applying our method to different batteries, different cell types, different cell sizes. And so currently our focus is on validation projects with different types of batteries, different manufacturers in Europe. Within the next weeks, we will start additional pilots with cell manufacturers where we go into their facilities, do some measurements there to get more hands-on integrating this into their lines and get a better, test our assumptions. Does it integrate as we expected? It's called like that. And next steps will be integrating our approach into real production lines, not some pilot lines as we do right now, but more additionally, series production line will be our next steps we are aiming for by end of the year, beginning of next year. This would be, when we look on our roadmap, this will be our next step if everything goes as expected, hopefully. And this would be a big push for us. Yeah.
Great. So if you're a cell manufacturer out there wanting to save some money on the aging step, reach out to Paul and Thomas. So maybe finally looking a bit into the future and what Sphere and Limatica together are cooking under the hood. We heard a lot about data that is being generated, about understanding the data, especially short development cycles. Maybe we can talk the last couple of minutes a little bit about what we want to develop together, especially looking into the later phases of the battery. We discussed a lot about the production itself, but ultimately our goal is together to build something where we contribute with leveraging our AI tools to basically incorporate the data directly from the cell manufacturing line, so to understand lifetime of the battery. So in the end of line for end of life, so to say. Maybe you can elaborate a little bit on this as well.
Yeah, so the final goal, let's say, is to have already a prediction in place about the future battery performance when the battery leaves the factory. So this requires, of course, more data, more analytics, more than there's actually to it. So right now we have an end-of-line testing, which usually consists of sometimes a full charge-discharge cycle, sometimes not, and some internal resistance measurement, AC and DC. And this is essentially the data that the manufacturer collects during manufacturing. But what is actually needed is a much more clearer picture about the cell and its future performance, because this will also affect future business cases for the manufacturer or whoever is in the line. So we see that some OEMs try to become cell manufacturers, so they will have their hands on a huge chunk of the battery life, and they need to make sure that their predictions about their product match reality, because this affects essentially all investment decisions on how to create a fleet, for instance, how to create leasing offers. All this stuff depends on how good you can predict the performance of a cell.
It's a super nice example, actually, that car manufacturers become cell manufacturers, because these are the two worlds of Sphere and Limatica merging together as well, right? We need to understand the supply chain in a completely different way. We're not, and we see that with the Asians, with the Asian players, they're rarely just one or the other. BYD is a super nice example where they have a completely vertical integration from the cell completely up to the car and the powertrain, the battery pack. I think this is a nice analogy of what Limatica and Sphere are trying to bring together, to merge the application and the very complex and costly manufacturing process.
Yeah, and the more and the faster you learn about your cells, either from begin of life, let's say end of line in the manufacturing, and then incorporate the new knowledge that you collect during the use will help to create a much clearer picture very fast. So this will also create new business opportunities for selling batteries and battery-based products. Yeah, it's not just like, for instance, one example is energy storage. Right now they are working on making profit out of the price fluctuations of the renewables. But the clearer the picture gets with the battery performance, the better they are able to optimize the products and the more benefit they can create. So there's a huge potential on that.
Absolutely.
I mean, we always like to end our episodes with an important key message to our audience. So maybe if there's one key takeaway that you want battery players, maybe even specifically European battery players, to take away from today, what would that be?
Yeah, take on the data challenge together with us, I would say, because there are still huge gaps that need to be closed.
Awesome. And data, we see data is everywhere, right? As we heard in our other episodes, it's in the EV manufacturers, it's in the power tool industry, but it's also in the manufacturing itself.
So thank you guys very much for being part of this conversation today. We really appreciated your insights a lot. And to you guys, I hope you join us next month for our next episode of Espresso Talks.